through our Energy Resilience Fund. Following that, we have Ray Hughes joining us from Wellington Orbit. He's going to discuss his journey with ERF and the funding that they secured. So a little bit of housekeeping. During the session, there will be a live Q&A box. So if you do have any questions, if you just pop them in there, and either the team will answer as we're going along, or we will answer them at the end. Slides will be sent out after the session, and they'll also be on our website. So a bit of background to SIB. As a brief introduction, social investment business, we work with charities and social enterprises across the UK. We provide a mix of loans, grants and support, and have deployed and managed over £800 million since 2002 and supported over 6,000 organisations across the UK. We started working with CSE about 12 months ago, and they're a key partner on our Energy Resilience Fund, and they provide support and advice to applicants throughout the process. So background to the Energy Resilience Fund, it's the successor to the Key Fund pilot, which has just closed. We launched it about a year ago. It's for organisations that are based in England, that are charities and social enterprises who are looking to become more energy resilient, and that can be through property improvements or equipment and vehicles. It's a £15 million blended fund, so every successful applicant will receive 60% loan and 40% grant. We work with a range of partners, and this next slide shows you who some of those are. And if you choose to apply to the fund, you can pick any of those partners to work with. So in terms of what can be funded, from this slide, you can kind of get an idea that it's fairly wide ranging. It can be anything essentially, as long as it's to make an improvement and to make your organisation more energy resilient. Our website has further details and some case studies on what has been funded so far. We've had everything from solar panels, electric showers, minibuses, air source heat pumps, insulation, and an electric tractor, which was quite exciting. So ERF, there are some key fund terms. These are shown on here, and of course all the information, again, as I mentioned before, is on our website. The main things to look at here is the minimum request is 25,000 and the maximum is 250,000 per organisation. So you can put in multiple applications, but the maximum you can receive as a single organisation is £250,000. The loan term is between 2 to 10 years, and we do offer up to 12 months interest only in the first year if that's required. The loan is unsecured and there's no early repayment fees. For the eligibility criteria, as I mentioned before, it's only for organisations who are based in England. Need to have been operating for at least 2 years and had a turnover of £100,000 in your last accounts. Key thing to look at here is if you are applying to do property improvements and you lease the property, you do need to have a minimum of 12 years remaining on the lease. So if you are interested in applying, this is how to apply. Everything's online. Our website is actually really useful. It's got a lot of guidance, frequently asked questions on there. So please do have a look through that. And if you need anything further, you can drop us an email and ask them. Somebody will get back to you. So you apply online. You can choose the partner who you wish to work with. It might be ourselves. It might be somebody that you have an existing relationship with. If you're applying for property improvements, you will need an energy audit that's been completed within the last 2 years. If you don't have an audit, we can pay for one on your behalf, but just to be aware that isn't a standalone part of the fund, so you can't apply just for an energy audit. You need to have a clear idea of what you would like to do to your property. We have 3 providers who carry out our energy audits on our behalf, so they will visit your site to see what measures would work for you and your building. The report that each of the auditors produces is standardised, so it doesn't matter which auditor you get allocated, it will all be the same. If you are applying for equipment, so if you're applying for a vehicle or showers, for example, you will not need an audit for that. It purely is just based on 3 quotes for anything over £10,000. If you have had the audit or you're applying for property, once we have all that applying for equipment, once you have all that information, we'll then work with you to develop your application. The auditor will talk you through their report if needed, and CSE can offer up to 2 days support to help you with that process. And as it says there, you will be supported throughout the lifetime of the investment by a dedicated relationship manager at Social Investment Business. So hopefully that's given you a bit of background to the fund and what it can be used for. I'm now going to pass across to Robin and Steve, and they're going to talk about the low carbon energy and how it can help reduce your costs. Thanks.
Hi, hello everyone. Okay, Julie, hopefully you can see our entry screen, low carbon heating. Yeah, great, fantastic. Okay, let's kick off. So just go to the next slide. So very quickly, who is the Centre for Sustainable Energy? You may have heard of us, you may not. We're an energy charity based in Bristol. We have a number of kind of core work streams. We're focused on ending the suffering caused by cold homes and combating the climate crisis. And we do a lot of work in supporting people in fuel poverty. We have an advice line and a retrofit team that covers both domestic and also non-domestic. We support community organisations on energy, fuel poverty, retrofit. We also work with local and central government and on decarbonisation and energy plans. And also we're supporting the SIB Energy Resilience Fund. We can support you through the application process with any kind of technical buildings advice and sort of help you with your sort of priorities and strategies going forward. So let's just look at what we're going to cover in the next sort of 15-20 minutes or so. I'm just going to go over how heat pumps work. Heat pumps are one of the main sort of methods of low carbon heating. And I'm sure you've heard a lot of news in the press about heat pumps. Hopefully we can dispel some of the myths and give you some of the facts. We'll talk briefly about the different types of heat pumps. We'll also then touch on something called solar thermal, which is great for hot water, direct electric heating, and just a final few thoughts on sort of changing your heating system. So if you're in a position where you're thinking about your heating system is coming perhaps to the end of its life, there's some sort of key things that we think you should maybe consider. What we recommend is look at a big picture and build a picture of the current situation. So just consider, how is the building heated and managed at present? What kind of activities are taking place through the week? Is it different users in different rooms with requiring different levels of heat and comfort? Ask questions about when does the building feel comfortable? When is it uncomfortable? Who reports to you that the building is comfortable? Who reports to you that the building is uncomfortable? What are they doing? And all of this is just trying to build a picture of how the building performs internally and how it meets the needs of the users in terms of being a warm and comfortable space. So along with that, also we want to know how energy efficient the building is. So how much energy is being used to heat the building and keep all the users and occupants of the building warm and comfortable when they need to be. And then alongside that, obviously something that is very much in the news is indoor air quality at the moment. So we sort of suggest using things like simple monitors, which can look at air temperature. They can look at relative humidity and CO2 levels. So temperature is great if you can track the levels of air temperature in your building, so you can see sort of when the highs and lows are, so really understand what's going on. And then along with that, the sort of relative humidity. And ideally, humidity should be between sort of 40 and 60% for the best conditions indoors. If it's too damp, you can get problems potentially with sort of mold growth and health and respiratory health conditions. And then the other consideration is carbon dioxide, so CO2. We all breathe out CO2 when we're in a space, and the more people in that space, the more CO2 builds up in that area. So we need to think about how that affects the indoor air quality and the ventilation. So then look forward at what are your priorities for the building? Of course, what is your budget? Hopefully with all that information above, you can sort of build a sense of what's needed, and then ultimately All buildings tend to have some constraints and restrictions. So what actually is technically feasible is another important thing. And the graphic on the right-hand side just illustrates the carbon impact of different sort of heating methods. So, for example, an air source heat pump is way lower than a gas boiler or even an oil boiler. So there's lots of different things to balance up, and it really does depend on what your priorities are as to what route you want to take forward. So let's just give you a bit more background about different types of heat pumps.
Sorry. So I guess the most sort of common form of low carbon heating system are heat pumps. There's sort of a couple of different types. We have air source. That's where we're using the outside air as a sort of source of heat, and we can transfer that using water to underfloor heating systems or radiators. Air-to-air systems are slightly different. So that's taking heat from the outside air and then heating up the inside air. So that doesn't use radiators or underfloor pipes. We also have ground source heat pumps. That's where we can take heat from the ground. And we have water source heat pumps. That's where we can take heat from any water sources.
So let's just dig into a bit more the kind of principles of how heat pumps work. So essentially they're termed as low carbon because they produce, ideally if they're well fitted and well designed, 3 to 4 units of heat for every unit of electricity they use. So they're much lower impact than a gas boiler, for example. And there's a thing called the coefficient of performance, which is used to measure their efficiency. And this is the ratio of heat output to electricity input. So, for example, a COP, coefficient of performance, of 3 means 1 unit of electricity converts to 3 units of heat. And depending on the tariff you're on, or the tariff you can source from your supplier, or even if you need to change supplier, actually this can still work out cheaper than a gas supply, than gas central heating, even though electricity is actually 3 or 4 more times expensive than gas at the moment. So just, comparison, 1 kilowatt of gas produces less than 1 kilowatt of heat. It's approximately sort of 90% efficient, whereas a heat pump typically could be 300 to 400 times efficient. So there's a compelling argument for considering them as a really good option.
Hey, so I guess a bit more if you want to understand how they're sort of working. So we are taking heat from ambient air. Hang on, sorry. Heat could be sourced from the outside air or warmth from the ground. This is blown or pumped over a heat exchange surface of the exterior part of the heat pump. This heat is then warm enough to cause the refrigerant liquid in the heat pump to evaporate and turn. Oh, sorry. This is not going well. There's no. Where was I? The heat is warm enough to cause the refrigerant liquid in the heat pump to evaporate and turn into a gas. This gas is then moved through a compressor, which increases the pressure, causing its temperature to rise. And this gas, which is now been heated, is passed over the internal heat exchange surface. And then this heat can then either be blown around the home's interior or transferred into central heating and hot water systems. So as the heat is transferred into the home, the gas falls in temperature, causing it return to its liquid state. This cycle of reverse refrigeration repeats until your home or your community building reaches the required temperature setting on your thermostat.
So yeah, let's just go into a little bit more detail on the most sort of common types of heat pump, and probably the most common one that's fitted in most buildings is an air source heat pump. So it uses a wet central heating system. So this can be a radiator network with pipe works, or it can be underfloor heating, or a mix of both. It's most efficient at what's called low flow temperatures. So this is the temperature of the water that runs around the pipework, ideally somewhere between 35 to 50 degrees C. And it requires a little bit of a behavior shift. I mean, if you have a boiler, gas boiler at present, whether in your home or your own sort of community building, potentially it comes on and off at different times of the day, and has a sort of fairly rigid set timer. The difference with heat pumps is typically they're most efficient if they're left on in terms of switched on constantly during the sort of heating season, and they'll sort of come on when you program them to based on temperature settings. And generally you have a fairly small temperature difference between daytime and nighttime. So generally they're just sort of topping up the heat in the building all the time when it's needed to meet your required kind of temperature needs. You would also need potentially a hot water cylinder if you don't already have one. And one of the things we always try to sort of recommend is for people to look at reducing as much as they practically can the sort of heat loss in their building first before getting a sort of heat pump sized and specified for your premises.
Okay, so air-to-air heat pumps, they're a bit different. I guess similar sort of looking to air conditioning units, so people might be slightly more familiar with them. So unlike air to water, it directly heats the indoor air. They are quite good at providing sort of intermittent heating or even top-up heating. Lots of them are also able to provide cooling during the warmer months, so they can be suitable for a variety of different situations. They are used in smaller buildings, but they're equally used in larger buildings and offices. You can sort of get different systems now. Some are ductless and some have ducts. Hot water isn't usually provided, but that's not to say it can't be provided. So different systems do slightly different things. And they can be cheaper than air source heat pumps.
So just as sort of a third type of heat pump, and you may have heard of this, and you may have seen this in sort of building projects on TV and different things. It's quite requires a bit more of an intervention. Basically, a ground source heat pump absorbs heat from the ground via a sort of a set of horizontal or vertical collectors, which are essentially pipes that run either vertically or horizontally. Typically, it could be about 100 meters worth of pipe work. It is more efficient than the air source version, but air source heat pumps are catching up in terms of efficiency, and it takes the heat from the ground. And the heat, basically the temperature of the ground is a constant sort of 11 to 12 degrees if you go down about 2 meters. So they're using this preheated liquid in this pipe work to then convert into heating into your home or your community building. They do have a higher cost, and obviously you need an outside space, and perhaps typically it's suited for larger buildings or multiple properties, but actually can be really economic and really efficient. But again, with the same as the air source heat pump, there is a behavior shift. It doesn't sort of work at its best when it's being turned on and off like a gas boiler. It works best when it's left on most of the time when you need it.
Okay, so one of the questions that tends to crop up quite a lot is, do radiators need to be bigger? And that's sort of because if we are running lower flow temperatures, so if the temperature in the water in the pipes and in our radiators is lower, we actually need a larger surface area to give off the same amount of heat. So yeah, this question often comes up, and the answer is it sort of depends what size radiators you've already got. So some buildings may have radiators that actually are big enough. And one of the, I guess, the simpler ways to check this, you could potentially try turning down your heating system to a lower temperature and running it for longer, and then wandering around your building with a thermometer, and that might sort of help to give you an indication if your spaces are getting up to temperature or not, and that might sort of help to indicate if your radiators are suitably sized. If not, you might need to look to upgrade radiators to a slightly bigger size.
So just to round off this section, just a few things, sort of key things to kind of consider to get a sense of whether your building is suitable for, a heat pump of any kind. And first off, we'd say actually don't wait until your boiler is at the end of its life or right near the end of its life or is broken. Replace your heating system if you think your boiler or your heating system is sort of coming to that point. Don't wait too long to get it done. One of the key things to get this right is a heat loss survey. So this would determine the size of the heat pump, the sort of number and size of the radiators, whether you need to have any pipework replaced or additional pipework installed, and how that's sort of placed throughout the building. And as I sort of hinted at before, if you've got quite a high heat demand, it might be necessary to improve some of the fabric of the building, such as adding some more insulation or improving the windows and doors, but that may not always be necessary. And if you need a hot water system, you need a suitable location for this. If you've been relying on a combi boiler, for example, heat pumps don't work in the same way. You don't have the instant hot water that the combi boiler would provide, so you need space for a hot water cylinder and also space outside for the actual heat pump unit if it's an air source heat pump. The other thing is, of course, electrical connection. You need to potentially contact your district network operator to see if you would need an upgrade, depending on the size of the heat pump you would need. And as I say, it does require a bit of behavior change. The efficiency is kind of maximized when they're left on constantly. That doesn't necessarily mean they're running constantly, but they're left on so they can kick in whenever the thermostat requires them to. So it just requires a bit of a shift in heating control habits and things. And it is possible to find some time of use energy tariffs for heat pump use that can help also to reduce the running costs.
Okay, very quickly, just on solar thermal. They were, I guess, more common in times gone by. We sort of tend to see less of them these days. Most people tend to prefer solar panels because you can potentially use that electricity for different things. You can store it in a battery, or you can even try and sell it. Solar thermal, it's sort of gone out of fashion a bit, I guess, and I think a lot of that is around the maintenance requirements and the fact that it's always producing lots of hot water, so you do need to use the hot water. Otherwise, that can be a bit of an issue. It's not to say that they can't be helpful and they're not worth considering. It's just that solar PV tends to be more popular because it's a bit more flexible.
So something else that actually can work really well in kind of a community building situation is direct electric heating. And sometimes if this is kind of paired with, a wet central heating system that's powered by an air source heat pump, you can find that the air source heat pump will do most of the heating that the building needs. But then if there's particularly cold occasions or particular situations where you need a top up, then some, for example, infrared panels can work really well in just elevating the temperature a little bit. Or alternatively, if you've got a space which is used really infrequently, then infrared panels can quickly warm people up, and the objects in front of them, they are 100% efficient. So 1 unit of power goes in, 1 unit of heat energy comes out. There's no loss of efficiency in that sense. So there can be something worth considering in very specific situations, maybe as a top up to an air source heat pump system, or to heat spaces which aren't used that frequently.
Just a few things, I guess, to keep in mind if you are looking at heating systems and potentially getting quotes for stuff. It's just making sure that it's not just about fitting these things. They will need commissioning and setting up properly. You do need to make sure that whoever is doing this is going to give a good sort of handover, so you know what documentation you've got, what repair and maintenance might be needed, how to use it, asking questions around guarantees and warranties and that sort of thing. So yeah, good to try and get a picture of what's involved with servicing and what sort of safety checks you might need.
And just as a final slide, just to kind of circle back to the slide that we had at the beginning about the key considerations, ideally what we're aiming for is a heating system that provides comfortable temperatures for the particular uses of your building, however varied and different they might be and frequent or infrequent. It's got to be easy to use, easy to maintain, and easy actually ideally to replace, because not everything lasts forever, unfortunately. It's got to be quiet and unobtrusive and reliable. And ultimately, what we're all here want to be talking about is got to use energy efficiently and as cleanly as possible without incurring excessive cost. So we're just going to hand you back to Julie and a case study, I think.
You're on mute, Julie.
Sorry about that. Yeah, I'm now going to pass across to Ray Hughes from Wellington Orbit, who is one of our customers who's been through the ERF process. And he'll just talk a little bit through about his journey with that. Thanks, Ray.
Hopefully you can hear me. Yeah, right. Okay, start with that. We're a community benefit society and we've been trading as a community arts centre from 2019 from a former HSBC Bank building. In March 2023, we received, Telford and Wrekin Council received a government award under the Capital Regeneration Programme, which is very similar to the Levelling Up Fund. And this enabled us to own the building outright. And we've also been able to redevelop the first floor, with the second floor still to be redeveloped. Next slide, Julie. Yeah. Historically, we had a relationship with Resonance, one of the partners, and they alerted us to the ERF, although we were already aware of it. The CRP award was lower than our budget, unfortunately, quite considerably lower. There were potentially other grants available which did not include blended finance. Unfortunately, none of those would work for us because being a community benefit society, we were unfairly excluded from the eligibility. A series of meetings took place while we considered the best options for ourselves. Thanks, Julie. Eventually, we got funding of just over 33,000, being 60% loan and 40% grant. And we used that for air heat pump. We will consider in due course whether to similarly fund an additional pump for the second floor. We did not go for solar panels because the payback would not work on blended finance. We need a full grant for solar panels, and that was because it's not so much the installation of it, it's the access and also replacement of tiles which contain asbestos. Our experience has been very good. We've had assistance from Resonance throughout, and SIB were very efficient in supplying all the paperwork, and the interest capital was split for us, which saved me a little work there. They actually had a follow-up visit probably about 4 or 5 weeks ago, and to see us and what they paid for, and they were quite impressed with what we've actually done. Right, okay. The difference was we did a comparison between the finance costs, including debt service and the energy savings, which left us with a balancing figure, and that was compared against the additional income from the creation of 2 income-producing rooms on the first floor, as we were moving the admin office upstairs to the second floor. Failing that, it would have been remained on the first floor, and the income production would be lost. We've calculated that the balancing figure equates to 1 hour's rent per room per week, so it's very much to our advantage to get this. Okay, and the pros and cons. The pros, of course, are the support from Resonance and SIB, which has been excellent. The cons for us was the lack of full grant funding, exacerbated, as I say, by the conclusion of the community benefit societies from the alternative programs we got, because we would have preferred to actually get, we preferred to get full grants, but we couldn't get that because of that exclusion. Okay, I think that's it, Julie, isn't it?
It is. Thanks, Ray. That was really helpful.
Yeah.
I'm just wanting to see if we've got any questions and answers in the box. Could somebody just check to see what we have, please?
We've got one question here, which was, can a solar panel be used with direct heating systems on an off-grid site?
Yeah, so solar panels, I guess, tend to produce most of their energy when it's sort of sunnier outside, and obviously heating tends to be the opposite. So then they can help, but they're obviously not a perfect fit. So it's good to sort of consider that in mind and consider what sort of generation you're going to be getting and when you're looking to be using your heating system. Potentially battery storage might sort of help with some of that. But yeah, you'd have to sort of take a closer look at when you're using the building, when you'd be looking to do your heating, and when you might be generating solar. Does that answer that?
Yeah, I suppose just to add a small bit, I guess looking at the total power or the total heating demand you have for the buildings, how much heating will you need and how much solar power you will need to supply that, and whether in the winter when you need the heating the most, can the solar provide that power, or like you say, is there some other option like a battery? But even then, a battery may not fit quite exactly your power needs depending on how much heating you've got.
And one last bit to follow up, I guess, is just to be mindful that direct heating is not as efficient as a heat pump. So that's something else you might want to consider as well.
Thanks, guys. We've got a couple of other questions in there, which I think probably sit with us more than yourselves. So we've got one from Anne, who are wanting to install a heat pump in the next few years. So if they apply to the fund, would they get experts to help us with the process of sorting out exactly what we need to do? Yes. So you would be looking to apply to the fund. Just to be aware, the fund does close in May 2027. So you would need to be looking to install something prior to that. But if you have an idea of what you want to apply for, then yes, and that's kind of when the audit process would kick in. So you would go online, apply, say that you're wanting to install a heat pump, and that's when the auditor would come out and have a look at your property, make sure that it's suitable for a heat pump. I think obviously Robin and Steve have kind of covered some of those areas and suggested, when it would and wouldn't be suitable. And the auditor would kind of follow up with that as well. So hopefully that's helped. We have another question from Sophie about, have our grants and loans ever been used as a wider Heritage Fund grant project for restoration works? Yes, is the short answer. We've got quite a few going through Architectural Heritage Fund, and some other properties as well, which are part of a wider refurb project, and we just fund the energy part of that, which is a great way actually if your budget is limited and you need to do some value engineering and cut some works out. It's normally the energy bits that come out first. So yeah, we can certainly do that as part of that funding. And yes, so everything would need to be installed by May 27. That's correct. Sophie, we may have example of heritage projects online. If not, I can certainly put you in touch with Architectural Heritage Fund. If you sort of send us your email after this event, that would be helpful. And then we can get in touch and put you in touch with them, and they can give you some guidance along that as well. Okay, we've got a few more minutes, so I just wonder if there's any other questions. Are we like to have more funding after May 27? That's the big question. I think the chances are there probably will still be funding of some sort. I think obviously with the government sort of, legislation that they want to bring in, and all the sort of the new regulations that are coming in around energy efficiency in buildings and that type of thing, then yes, I think there will be some sort of funding, whether it's our funding or somebody else, I can't tell you from that. So where does our money come from? So it comes from Access and Big Society Capital. So some of it is government funding, if you like. So yeah, it all comes down to kind of public money for this particular fund, and then we have a range of other funds on our website that you can have a look at as well. How long does a typical application process take? That can vary. It would depend if you're asking for equipment or property. So the audit can take up to 45 working days. So yeah, it really just depends on sort of how quickly you respond to us and how quickly we can get an auditor out and that type of thing. So Caroline, the slides are going to be sent out to everybody, so it will go into detail about what can be funded, but also that's all on our website as well. Again, the links will all be in there. The success rate, I say the success rate for applicants is fairly high. We're not currently oversubscribed. There is funding still available. What I would suggest, if you've got a particular project in mind, that you drop one of us an email after this session and we can get in touch with you and then talk about a specific project. Okay. So I think we'll start to bring an end to the session there. Thank you very much for attending. I hope you found it useful. This was our third session, so we are looking to run 2 more sessions after this one. Next one is on 30th of April, which is about renewable energy generation. We will be having another live case study from an organisation who secured funding. So they had 2 applications with us. One was for solar panels on their sports hall, and the other was for LED floodlights on the AstroTurf pitch. So you can see it's quite a varied sort of group of applications that have been through our process. As I mentioned earlier, slides will be sent out. Everything will be shared on our website, so please do have a look on there. We'll also be sending up a follow-up survey, so if you could spend a couple of minutes just to complete that, just that we know that we're kind of delivering what people actually want. Thank you again for your time this afternoon. I hope you found it useful, and yeah, please do sign up. Link should be in the chat for the other 2 sessions. Please do sign up for those, and we'll see you next time. Thanks so much now. Bye.
Thanks, everyone.
Thanks.